All right, so it's 10 o'clock, so I guess we can go ahead and get going. So I'm Fox. I will be your teacher for the first half of the course, and then for the second half of the course, Diego Rojas is going to go ahead and take over. So I guess just a few things before we get started. I'll go over the syllabus real quick. Just as a heads up, so class, actually attending the WebEx thing is optional. I just thought it'd be a good idea to give you the option to join live just in case you wanted to ask questions along the way or things like that, or slow me down a little bit. So that's fine. Can you all see the syllabus on the screen?
Yeah.
Okay,
Yeah.
perfect. So like I said, I'm Fox. I'm one of the instructors. The other instructor is Diego. My office hours are going to be Monday and Tuesday right after this from 11 to 12, and his are going to be Thursday and Friday from 11 to 12. And then we have a grader whose office hours are going to be posted soon. There's the textbook right there. If we come over to Canvas, there's a red shelf, course materials, and that's where you can go to access the textbook and also Pearson's MyMathLab, which we will be using for the homework. Let's see, other things, you guys can, read most of this. The homework will be via MyMathLab and will be due each Sunday at midnight. The grading policy, homework is 25%, quizzes are 25%. There will be one midterm and one final, each worth 25%. And I guess this is the tentative grade lines. So that's chill. Oh, Diego just joined the meeting. So howdy,
Hello,
Diego.
everyone.
Hi.
My name is Diego Rojas. I'll be your other instructor for this class.
Yep. So other than that, quizzes. I mean, it's an online class, so it's not too much that can be done, about books and stuff. So all the quizzes and stuff are going to be open book, open note, everything. But you just can't use any computer algebra software like Wolfram or things like that. Let's see. So the exams are right here. We've got the midterm and the final. The midterm being on June 12th, and the final being on July 10th. And there is all these sections that will be covered on the midterms and final. And everything else is pretty much just stuff we have to put in there, so that's okay. So I think that's pretty much it for the syllabus. So does anyone have any questions on that? Cool. Then let's pop over to I have to stop sharing Google Chrome and pop over to the Penbook where the notes are. So share content and Penbook. Okay. So now we'll pop over to Penbook. All right. Let's see. Can you all see this? Look, can you see the real number? Okay, perfect. So I guess just starting in here, we're starting in, sort of nice and easy. So just as a reminder, about the number system. So we've got natural numbers, and that's going to be things like 1, 2, 3, etc. But it's not going to include 0, and it's not going to include any of the negative numbers or anything. Then after that, we've got not the whole numbers, but the integers. Let me write that real quick. Integers. And the integers are going to be -3, -2, -1, 0, 1, 2, 3. Basically, all the numbers that were in the natural numbers, except you've got 0 and you've got our negatives. Okay, so that's fine. That's not too bad. After that, then we've got our rational numbers, and we're just should be given some examples here. So like -4, 0, I don't know, -3 halves. Let's see, 2/3, sure. Basically anything that can be written as a fraction. So those are our rational numbers. Irrational numbers are, well, everything that we've discussed previously, but then, we add in things like the square root of 2 or pi, things like this. Things that don't have a fraction addition. So that's fine. And then the real numbers are going to be we add in all the rationals and the irrationals. So rationals and irrationals. Okay, so that's not too bad. That's just sort of going over, what the numbers are, just as a quick little reminder. So let's go ahead and jump into the properties, because this is where things actually start to get pretty important. Let me pull up my clock so that I know how we're doing on time. Oh, we're doing fine. Okay, cool. So for properties for addition, so remember, if we have a plus b plus c, well, that's the same thing as we can move the parentheses around. So a plus b plus c. Okay, so that's not too bad. Then we've also got the commutative property, which says that a plus b is equal to b plus a. So again, not too bad, just sort of reviewing things. We've got an identity, the identity being 0. So all that basically means is if you add 0 to anything, you get what you started with. And that's not too bad. And then we can always undo whatever we have. So if we take a and we add negative a, we'll always get back to 0, which we call the identity. Perfect. All right, so and just I guess let's move on to the multiplication piece. So everything's pretty much going to be the same except with multiplication. So if we have AB times C, well, it doesn't matter if we multiply AB and then multiply by C, or we do BC and then multiply by A. Those are going to be the exact same thing. Commutativity says A times B is equal to B times A, so it doesn't matter the order in which we multiply things. We also have an identity for multiplication. This one is 1, right? So A times 1 is just going to be A.
Could you move the notes up? We're having issues difficulty seeing.
Let's see. How do I move the notes up? That's probably not helpful, is it? Is that better?
No.
No.
Okay.
We can only see the addition part.
You can only see the multiplication part?
Yeah, the associative and commutative. That's about it. We can't see.
Yeah,
Okay.
they can only see up to identity, I believe. And
Yeah, that's about it.
you need to make it bigger.
Okay, I'm not quite sure how to do that. Let's see. That's not going to... Okay, well, I guess we will add another page. Sure. How do we do that? That's... All right, and then we'll move this page up here to there. Cool. All right, cool. So we've also got the, could you guys see identity?
No.
Okay, then we'll go ahead and do that. So we've also got the identity for multiplication, and that's going to say that a times 1 is just equal to a. So if you multiply anything by 1, you get back to a. So that's fine. And lastly, we have inverses. So inverses. And inverses is going to say that a times 1 over a is going to get us back to the identity. All right. Cool. So that pretty much gives us all our properties that we need for addition and multiplication. So I guess going down, if we just want to, and the last thing we need is the distributive law, which says how they work together. So that says if we have a times b plus c, that's the same thing as what we can distribute. So ab plus ac, and you can think of it as the a goes here and the a goes here, and then you multiply them together, or you add them together. Excuse me. So that's the distributive law. So I guess just seeing a few examples with actual numbers, right? So 7 plus x is the same thing as x plus 7, right? Nothing totally surprising there. If we have 4 and we multiply by 1/4, well, that's just going to be 1. Okay, fine. And if we have 5 times 3 plus 4, okay, so we can do this a few different ways, right? So we can say 5 times 3 plus 4 is 7. 5 times 7 is going to be 35. We can use our distributive law up there. Right, so that's going to say we take 5 times 3 and add that to 5 times 4. Right? 5 times 3 is 15. 5 times 4 is 20. This is going to give us 35. So we could either use the distributive law, or we could sort of use just add what's in the parentheses first and then multiply. Oops, excuse me. All right. So a few things that we should watch out for, right, are negatives, because negatives tend to trip people up. So just as a review, what is a negative times a negative?
A positive.
Perfect, yeah. So negative times negative is going to be positive A. So a negative times a positive is going to be then a negative, right? So we have that negative A times B is going to be negative AB. But it doesn't really matter where the negative is. We could also have written this as A times negative B. All right. We just said a negative times a negative was going to be a positive, right? So this is just going to be A times B. And here, negative 1 times A, well, that's just going to be negative A, right? Because the 1 is just understood, so to speak. And lastly, anything times 0, well, that's a nice one. Anything times 0 is just always going to be 0. Perfect. All right, and an important thing that will come up later in the semester is when does AB equal 0? And AB will equal 0 if and only if A equals 0 or B equals 0. So what this says is if A equals 0 or B equals 0, well, anything times 0 is 0, so their product is going to be 0. But on the other hand, if we have two things that are multiplied, which equals 0, one of them is forced to be 0.
Hey, Fox.
Yeah.
The students can't see the bottom of the page. Is there any way
Yeah.
to scroll down?
There's no way to scroll down. Can you see this?
We're still at the negatives and at the traps, which is bracket -1
Sure.
multiplied by A.
Um,
We're still there.
I thought that you guys could see down to there. Okay.
No.
I guess I will be finding a new program for tomorrow. Let me copy all this stuff. Copy, and then I suppose we will make another new page and post this thing. And then we'll do this. If you can figure out how. All right, so it goes right there. Perfect. All right. So yeah, just continuing on. -1 times A is going to be negative A. A times 0 is always going to be 0. And then just to repeat now that it's on the screen, remember, so if AB equals 0, well, I guess let's do the other side first. So if A equals 0 or B equals 0, well, anything times 0 is 0 because of this little product right here. So what that's going to say is, well, yeah, the product is 0. But on the other hand, if we have two things that are multiplied together, and together their product is 0, one of them is forced to be 0. All right. Everyone with me so far? What?
Yeah, we're on it.
Okay, perfect. All right, so I guess the next big thing to talk about is fraction properties. I'm guessing you guys can't see the example at the bottom.
Is that correct?
Correct.
Okay.
Yeah, last common denominator.
Okay, perfect. Then, fine. At least I know this time. Okay. So, with fraction properties, we've got cross multiplication, right? So that's going to say that if A over B is equal to C over D, well, that's the same as saying that A times D, but that's a horrible A. A times D is the same thing as B times C. All right, so we can cross multiply and we still obtain something that is true. Perfect. For cancellation, we have that KA over KB. So if we have a fraction A over B and both of them are multiplied by K in the numerator and the denominator, remember the top is the numerator and the bottom is the denominator, then we can cancel and just get A over B. Perfect. So that's fine. For multiplication, so if we have A over B times C over D, well, if you have two fractions and they're multiplied together, well, you just multiply across the top and multiply across the bottom. Right? So this is going to be AC over BD. Cool. And lastly, we've got, or I guess not quite lastly, we have division, which is going to say if we have A over B divided by C over D, well, we invert and multiply, right? So we invert the second one, the thing we're dividing by, to get A over B times D over C. And then once we've inverted, like I said, we just multiply. So this is AD over BC. All right. Perfect. So if we want to add fractions together, so suppose we had A over B plus C over B. All right, well, there's an important thing to notice here, and that thing is that the denominator is the same. So if we're going to add fractions, we need to have a common denominator. And so that's going to be A plus C over B. Right, and similarly with subtraction, if we have A over B minus C over B, well, as long as we have that common denominator right there, then it's going to be A minus C over B. Perfect, so lastly, we just have common denominators. And so that's going to say if we have A over B plus C over D, well, if we want to add these two together, we need to get a common denominator. So one of the easiest ways to do that is multiply the left side by D. So let's use red. So D times A over B plus, and then we multiply the other side by B. So B times C over D. D over D is what we want. B over B. My bad. D over D and B over B. Perfect. And then that's going to give us, now both have BD as their denominator. So this is going to be DA plus BC all over BD. Perfect. And that's how we get common denominators. Can everyone see that last line?
No, only the first half.
All right, I will move that up here then. Perfect. How's that?
It's good.
Okay, perfect. So now, I guess let's move my example to another page as well. All right. Where do we go for that? Oh, right here. Okay, perfect. So, okay, so example. We want to find the sales tax that is owed on a purchase of $947.69 if the sales tax is 6.5%. Okay, so this is going to deal with a few things, right? So we need to, if we want to figure out how much is owed or how much the sales tax is, well, we need to take 6.5% and we need to multiply that by $947.69. Okay, so that's fine, but put a dollar sign right there, I guess. But the issue is we can't just multiply percents with dollars, right? Because percents are kind of funky. So if we want to actually multiply this, we have to change the percent to a decimal or a fraction, right? And so if we want to change it to a decimal, well, remember we just we divide by 100, right? So that's going to say that 6.5% is the same thing as 0.065 times 947 and 69 cents. Perfect. Okay, so now if we just do this multiplication real quick on a calculator or something, we're going to wind up that the sales tax is 61 cents, 60 cents. Cool. All right. Everyone with me so far? So that's not too bad. I guess, so let's move on to section 8.5. Okay. So this one is integer exponents and scientific notation. Okay. So let's go ahead and tackle this. So the best way to do this, I think, is just to sort of jump into the definition, right? So suppose we have something a to the n. If n is positive, well, then that just means that we are multiplying it together n times. So, right, so a times dot times a, and this is going to happen n times. Right, so, you know, if we had, we'll do it in green, sure. A cubed, well then that's a times a, right? Because that's just a multiplied to itself 3 times. Perfect. So if we have a to the 0, right, if n is equal to 0, well, what's anything to the 0th power?
0.
So if we close. If we multiply something by 0, it's going to give us 0. But if we raise something to the 0th power, it's going to
It's
be
1.
1. Perfect.
Yeah.
Perfect. So the only exception is a can't be 0. I'll write that in red to show warning, right? So that's not red. All right, so a cannot be 0. Right, because if we raise 0 to the 0th power, well, we don't quite know what's going to happen, because, you know, how can 0 become 1? Let's see, and lastly, if n is negative, well, if we have a to the negative n, then this is going to be 1 over, if n is negative, then a to the n is going to be 1 over a to the negative n, right? And so, because remember, n is negative, when we move that negative in front of the n, it's going to make it positive. So let me give an example real quick, because that's a little bit on the abstract side. So basically, if we have a to the negative, that looks like a u, doesn't it? If we have a to the negative third, well, that's just going to be 1 over negative 3, which is a cubed. Perfect. Okay. So if you have a negative power, you can just move it to the denominator. Perfect. All right, so of course you're not going to be able to read these, so let me move the properties to another page. Copy. All right. All right. Cool. So paste. So let's tackle these properties. Okay. So if we have a to the m times a to the n, well, if we multiply things that have the same base, but what do we do with their exponents?
You plus.
Yeah, we add them. Perfect. So a to the m times a to the n is going to be a to the m plus n. Okay. Cool. So now, on the other hand, what if we have a to the n all raised to the m power? What happens here?
Equals to a and m.
Yep, perfect. So a to the n times n. And the way I like to think about this is, okay, well, I see parentheses. Parentheses almost always mean multiplication, right? So if we have a to the n times, or a to the n to the m, well, there's a parenthesis in there. Great, okay, that's going to mean that we multiply. So a to the n to the m is going to be a to the n times n. And just as I guess for reference, we can also write this as a to the m to the n. It doesn't matter which power we do first. Okay. Let's see, if we have a times b to the m, well, this is going to be a to the m times b to the m. So if we have two things which are multiplied together in parentheses, and the whole thing is raised to the mth power, well, then we can just distribute the power to both things. But I guess as a word of warning, if we have a plus b to the m, this is not the same thing as a to the m plus b to the m. You got to be very careful on that. That is not true. Right? Not true. Okay. So perfect. Okay, so right, just like with multiplication, division works the same way. So this is a to the m over b to the m. Right, and lastly, just sort of like property 1, if we have two things with the same base who are being divided, well, we can rewrite this as a to the m minus n. So you take the top power and subtract from it the bottom power. Okay. So that's everything with exponent properties. Okay, that's fine. So, oh, I forgot to move this, didn't I? Oh, no, I didn't. So yeah, so let's go ahead and run through some examples. Okay, so if we have 2x cubed times 3x to the 5th, well, the 2 and the 3 don't have any exponents on them, so we can just multiply those together. So that's going to be 2 times 3, right? And then times x cubed times x to the 5th. Okay, well, if we have exponents which are being multiplied together, then we add them, right? So this is going to be 2 times 3 is 6, and x cubed times x to the 5th is going to be, yep, perfect, x to the 8th.
Okay.
Perfect. I'm almost out of tea, saying. Okay, so with this one, so we can't use that last property that we talked about, this one right here, for this problem, right? Because x and y are different bases, right? So instead, if we want to simplify, well, we don't generally like to have negative powers in our equations just because they're obnoxious, right? So the best we can do for this is say, okay, well, we know if we have a negative power, we flip where it is. So this is going to be the same thing as 1 over x 1 over x cubed times y to the 4th, right, which is just y to the 4th over x cubed. So horrible. Okay, perfect. So that's that one. Let's pop to the next one, right? So if we have this one, so let's go ahead and simplify it again. So I would rewrite this as 1 over u to the negative cubed b squared squared. Right? Now we can go ahead and apply our powers, right? So remember, if it's parentheses, we multiply the powers. So u to the negative third times 2 is going to be u to the negative 6th, right? V squared squared, 2 times 2 is 4. So we get, oh, that should be 4. So we get u to the negative 6 v to the 4th. Right, but if we have a negative power, we can move it up. So this is going to be u to the 6th over v to the 4th. And again, that's as much as we can do because the top is u and the bottom is v, and those are different. Perfect. Okay, so lastly, if we want to write this as a simple fraction with positive exponents, so on this one we have to be careful. Right, and I will show you why, but I'm worried about running out of space, which seems to be the key, or which seems to happen frequently. So we'll copy this and move it onto another page. Right. Okay. Perfect. And then paste it. What an efficient process we have going. Okay, perfect. So one thing that we can't do is, so the bottom, sorry, I'll make it big. Right? So the bottom has more than just x to the negative first, right? So what that means is 1 minus x over x to the negative first. Well, we can't just say x to the negative first is just going to be x, and so we can move that to the top. This is not true, right? And again, the reason is because we have this extra negative 1 out front. So multiplication is okay to do that with. Addition is not. So let's figure out how we can actually do this. So I suppose I'll put the actual solution in green. So 1 minus x over x to the negative first minus 1. Okay, well, let's rewrite this as 1 minus x over 1 over x minus 1. Alright, now we don't tend to like fractions within fractions, so if we want to get rid of that 1 over x, what would we have to do?
Would you multiply by 1?
Yeah, so we're going to want to multiply the whole thing by 1, but we're going to want to do it a clever way. So if we want to get rid of 1 over x, well, we're going to have to multiply by x, right? So we know we want to multiply the bottom by x. So 1 over x minus 1. But we can't just multiply by x. Oh, that was the table. We can't just multiply by x, right? Because what we do to the top, we have to do to the bottom. So just like when you're working with equations, what you do to one side, you have to do to the other. Right, so we also have to multiply x on top. So x, 1 minus x. Right, and this is sort of like the reverse cancellation property. Oh god, my foot's asleep. Right, so if we cancel the x's, we would be back to exactly where we started. So, but this is nice, so then we can move the x into the bottom. Right, so this is going to be x times 1 minus x over, okay, well, x times 1 over x is just going to be 1. And then x times negative 1 is going to be negative x, so that's fine. But now we have a 1 over x in the top and a 1 over x in the bottom, so we can go ahead and cancel that, and we'll just get an x in total. Morning. Perfect. So if we want to write 1 over x inverse minus 1 as a simple fraction with positive exponents, then that's just going to be 1 over x, then that's just going to be x. Can everyone see that down to the bottom?
Could you move it over again, please?
Run it over again? Sure. Perfect. So, starting from let me pick a different color. All right, so starting from here, Packers colors.
We can't see the bottom of the page.
Okay, sure.
Yeah, you need to move the last line up. Yeah, there you go.
Yeah.
Okay, perfect. So, right, so the first step is going to be move x inverse from x to the negative first to 1 over x. Right, because that's really the only thing that we can do at the start. All right, but from there, we don't like fractions with fractions, right? They're disgusting and obnoxious and hard to deal with. So we want to try and get that out. So the way that we want to do that is by multiplying by 1. Because we can always do one of two things to an equation. We can either add 0, right? Because 0 is the additive identity, it's not going to change anything. Or we can multiply by 1, because again, multiplying by 1 doesn't change anything. It doesn't affect the value of the equation. So what we're saying here is, okay, well, that 1 over x is obnoxious. I don't want it to be a fraction. So let's multiply by x, right? Because x times 1 over x is just 1. So in other words, we're going to get rid of that fraction. So if we multiply the top and bottom by x, then that brings us to this step. And so lastly, let's distribute the x in there, in the bottom. So if we distribute the x in the bottom, then x times 1 over x is just going to be 1, right here. X times negative 1 is just going to be negative x. So in the bottom, we're going to be left with 1 minus x. And in the top, we have x times 1 minus x. Now, the trick here is we have a factor and factor is basically just one term, right? So we have a factor of 1 minus x in the top, and we have a factor of 1 minus x in the bottom. And if we have a factor of those, then we can just cancel them, right? Because it's the same thing, we can use our cancellation property. And if we cancel those with red, sure, oh no, red is bad color, we'll use blue. Then all that's left is the x, right? And so that brings us here. Does that make sense?
No.
What part is confusing?
The third part when x parentheses 1 minus x, why didn't you multiply it? Why did you just leave it as it is instead of multiplying?
In the top?
Yeah.
Right, because if I do that, then I have a factor of 1 minus x up here, and I get a factor of 1 minus x down there. And so the reason that's nice is because then I can cancel them. And
Okay.
yeah, then they go away and I'm just left with it.
Got it.
Perfect.
I'm still confused on the part right before, like where it says x times 1 minus x over x times 1 over x
This part?
minus 1. Yeah.
Like you're confused why the x's showed up?
Well, I'm just confused how you went from that and then times the denominator and got the 1 minus x. I guess I didn't really see how you do that.
Oh, sure. Okay, let me write that up here, right? So in, I guess, scratch work, so x times 1 over x minus 1. Okay, well, we use our distributive property, right? So, let me change to a different color because colors are good. Let's do purple. Purple's a good color. I like purple. Okay, so we can use our distributive property, right? And so that's going to say that we have x times 1 over x minus x times 1.
Mm-hmm.
Right, now x times 1 over x, well, that's just going to be 1.
Right.
And then x times 1 is just x.
Okay, I see. Thanks.
Yep. Perfect. All right. Perfect. Okay. So let's go ahead and move over to scientific notation. Okay, so this is just, a quick thing. I think the best way to do scientific notation is just to, give you a few examples. I don't think we're going to use it too terribly much in this class. So, so for scientific notation, scientific notation is writing whatever number we have as something between 1 and 10 times a power of 10. So, for example, 7 is 7 times 10 to the 0, right? Because 10 to the 0 is 1. And so we just went up back with 7. And the reason this is nice isn't for things like 7, it's for things like 45 hundredths, right? Because then we can say, okay, well, this is going to be the same thing as 4.5 times 10 to the negative first. Right, so it gives us, it's an easier way for us to think of something. Because, for example, 5.8 is an easier number for us to wrap our head around than, for example, 580, which is what this number is. Or, these are sort of toy examples, but it gets much harder if we have something like 0.000056. Okay, well, that's kind of an awful number to look at, right? And it's not convenient to represent. So we use scientific notation as a way to make it just look a little bit nicer, right? And so I guess, these are sort of on the left examples we can just sort of do because they're a little bit smaller, but on the right it's a little bit harder. So if we want to think about how to do this, the way, the pen is not working. 1 sec. That's obnoxious. Technical difficulties. We're working now, perfect. Okay, so the way I like to do this is say, okay, well, how many spaces am I going to move it over? So I'm going to move it over 1, 2, 3, 4, 5, right? And so that was 5 towards the decimal piece, right? So this is going to be 5.6 times 10 to the negative fifth. So that's just a quick thing on scientific notation. We're not going to worry too much about that. I just thought I would go over it real quick as just a check, just so that we'd see it. I'm going to have to move the stuff at the bottom to another page, so go ahead and copy that. But I think we can see this stuff right here. So let's move on to rational exponents. Okay, so with rational exponents, we're now not just concerned with, so instead of being concerned with r squared equals 36, well, that's great, but we want to know what r is, right? And so we need the concept of fractional powers, right? So r would be then the square root of 36. Oh, that's a horrible 6. Right, which we can think of as 36 to the 1/2 power, which we know is just going to be 6. But so rational exponents are just going to be things of the form a to the m over n. So let's go ahead and do a few examples on another piece. Paste. Okay, and then we're over here. Okay, perfect. So, right, so 4 to the 1/2, which is the same thing as the square root of 4, right? Well, what is the square root of 4? Well, the square root of 4 is just going to be 2, right? Because 2 times 2 is going to be 4, right? So now we have to be a little bit careful. Let's look at the square root of negative 4. All right, well, if you try to take the square root of a negative number, it's not going to exist. So this is not a real number. So if you get a square root of a negative number, you've probably done something wrong. So that's a nice little check that you can use for yourself. Let's see. So right, if we have 8 to the 1/3 power, remember we can write that as the cubed root of 8. So it's like the square root, except there's just a little 3 inside it. Right, and so the cubed root of 8 is just going to be 2. Right? And the way we think about that is, right, 2 cubed is 8. So that's going to say that the cubed root of 8 is 2. Okay, so that's fine. Now, if we have negative 8 to the 1/3 power, the cubed root of negative 8. So here things are a little bit different. So we can take a fractional power of a negative number so long as that number is not even, right? So if we have a 3 or a 5 or a 7, we can take the 3rd or 5th or 7th root of a negative number, but we can't take the square root or the 4th root or the 6th root of a negative number. That's not going to work. But so this is just going to be negative 2. Yeah, and so in general, if we have something of the form b to the m over n, well, we have a few ways of doing this. We can do b to the m to the 1 over n, which is the same thing as the nth root of b to the m. Or we can write this as b to the 1 over n to the nth power, which is the same thing as the nth root of b all to the nth power. Perfect. All right. Are there any questions on that so far? All right, cool. Then, let's go ahead and move to some examples. All right. So, suppose that we have 3u squared v cubed to the 3/5 power, and we want to simplify this as best we can. Okay, well that's going to be, remember we can move powers in, right? So this is going to be 3 to the 3/5 power, right? Then u squared, u squared to the 3/5 power, v cubed to the 3/5 power, right? And now we can just multiply. So this is going to be 3 to the 3/5 power times u to the 6/5 power. V to the 3 times 3 is 9/5 power. Okay. Perfect. So that's that. If we have the square root of x squared plus y squared, all that we can really do here is rewrite it as x squared plus y squared to the 1/2. So just like I said, when you have, a plus b to some power, it's not, a to that power plus b to that power. What that means is we can't split up square roots over addition. So I guess putting it over here, that says that the square root of x squared plus y squared is not equal to the square root of x squared plus the square root of y squared. Perfect. Okay. If we have -8 to the 5/3 power, well, we can rewrite this as -8 to the 1/3 to the 5th. Okay, but we know that the cubed root of -8 is -2. Right, and so if we raise that to the 5th power, well, -2 to the 5th power is just going to be -32. And you can check that with the calculator. Alright, so lastly, we come to this example. Well, are there any questions so far? Are we all good? Okay, cool. So lastly, if we come to this example, so this one we have to be a little bit careful on. So we're going to use the distributive law, but we have to use it in a careful way, right? So, let me get a different color. So if we want to use the distributive law, well, this term is going to get distributed to this one, and this term is going to get distributed to this one and this one. Wow, what a great color combination, purple and brown. I'm a genius. Okay. So let's go ahead and FOIL this out. So this is going to be this term times this term. Right, so that's going to be 2x to the 1/2 times x to the 1/2. Then minus 2 times 3 is 6, so x to the 1/2, y to the 1/2. Then plus, okay, well the coefficient on this one is 1, and the coefficient on this one is also 1, so 1 times 1 is 1, and we're going to get x to the, I'll write it this way, y to the 1/2, x to the 1/2. And then lastly, we're going to get minus 3y to the 1/2, y to the 1/2. Okay. Can everyone see this squiggle? Just so I know I'm not going too far down.
Yep.
Yeah.
Okay, perfect. So, okay, so now if we want to combine things, well, x to the 1/2 times x to the 1/2, well, that's just going to be x to the 1, right? Because 1/2 plus 1/2 is 1. So this is going to be 2x. Then we have x to the 1/2, y to the 1/2, and then y to the 1/2, x to the 1/2. But y to the 1/2, x to the 1/2 is the same thing as x to the 1/2, y to the 1/2. So -6 plus 1 is actually going to be -5x to the 1/2, y to the 1/2. Right, and we cannot simplify these two because they have different bases, x and y. And lastly, for the same reason that this one is 2x, this last one is going to be minus 3y. Okay. How do we feel about that? Alrighty. So let me copy this page that we almost had room for, but not even close. So let's go over some quick properties. Right, so if we have the nth root of x to the n, well, we can think of those as just canceling, right? So this is just going to be x. If we have the nth root of x times y, well then that's going to be the nth root of x times the nth root of y. So in other words, radicals split up over multiplication but not addition. And lastly, we have if we have division, it's the same thing, right? So the nth root of x over y is the same thing as the nth root of x over the nth root of y. All right, cool. So now if we come over here to some examples, well, if we have the fourth root of 3x to the fourth y cubed all to the fourth power, well, it's something to the fourth power, and we're taking the fourth root of that. Oh. So that's just going to be 3x to the fourth y cubed. And if we come down here to this example, well, the fourth root of 8 times the fourth root of 2, we're taking the fourth root of both of them and we're multiplying. Right, so this is the fourth root of 8 times 2, right, which is going to be the fourth root of 16. And if we take the fourth root of 16, you can check that that's going to be 2. Okay. Have I lost anybody so far? Okay. Perfect. So, I guess there's only one last thing that I wanted to run over real quick, and that's rationalizing numerators and denominators. Because oftentimes I think your homework will ask you to present the answer with the denominator rationalized. So let's go ahead and do this. So rationalizing the denominator means just we want to get the square root out of the denominator. Just the same thing as rationalizing the numerator means we want to get all square roots out of the numerator. So if we want to rationalize the denominator of this, well, in order to get rid of the square root of 2x, we're probably going to want to multiply by 2x, right? Because that's going to cancel the square roots. So what that's going to say is 6x over the square root of 2x is going to be equal to, well, okay, so again, we're just going to multiply by 1 in a clever way, but we're going to multiply by the square root of 2x over square root of 2x. Okay, oh, sorry, square root of 2x. Right now, the square root of 2x times the square root of 2x is just going to be 2x. So we're going to get square root of 2x times 6x over 2x. Okay, but then the x's are going to cancel. And 6 over 2 is 3. So we're going to wind up with 3 square roots of 2x. Alright, questions on that one? Cool. Alright, so let's move on to a little bit harder one. So rationalizing the denominator of this bad boy, x minus 4 over the square root of x plus 2. Right, so if we have, so this one is different, right, because now we have things that are added here. So the way that we're going to want to get rid of them is going to be by multiplying by the conjugate. And the conjugate just means that we take whatever we had. So instead of x plus 2, the conjugate is going to be x minus 2. So writing this out, x minus 4 over the square root of x plus 2 is going to be equal to x minus 4 over the square root of x. Oh, too much. Square root of x plus 2 times square root of x minus 2 over square root of x minus 2. Right, so I took whatever this is, whatever I wanted to get rid of, the square root in, and I multiplied by its conjugate. So I just flipped the sign in the middle. Alright, so that's fine. So that's going to give us square root of x minus 2 times x minus 4 over. Okay, so I'll leave this to you guys to check in an exercise. But if we multiply these two together, we're going to get x minus 4. Okay. So now, again, just like that problem before, we have an x minus 4 over an x minus 4. Those are going to cancel and just leave us with the square root of x minus 2. Okay, that one's a little harder. Are there questions on that one? Okay. So lastly, we just have to rationalize the, now we want to rationalize the numerator. But if we want to rationalize the numerator, well, we play the same trick. We're going to have to use this idea of the conjugate, right? So we're going to 3 plus the square root of m over 9 minus m, and we're going to multiply by 3 minus the square root of m over 3 minus the square root of m. And again, I'll leave it to you guys to check. In the numerator, we're going to get 9 minus m over 9 minus m, 3 minus square root of m. But again, those are going to cancel, and we're just going to be left with 1 over 3 minus the square root of m. Okay. Questions on that? Cool. Well, I guess that's it then for our first class.
Yeah. Real quick,
Yeah.
a student is asking if the notes are going to be available on Canvas.
Yes, they will. I will post them at some point today.
There you go.
So let me go ahead and stop sharing. Okay. Cool. Yeah. So I guess that's it. I will. Next time I will find a way to. Or I will see if I can use a different program or make the notes a little bit so that you can see the whole thing. Yeah, and just as a heads up, when I have the pen book thing open, I can't see any of your chat things. So you'll have to let me know with words. Oh no. But I think that's pretty much it. If there's no other questions, yeah, I will.
I have one more question. What about the Red Shelf course? Like, do we have to subscribe to it or anything?
Yeah, so you will have to you'll have to purchase an access code for the ebook and for Pearson's My Math Lab, and that should be able to be done through the bookstore.
Okay. Okay.
Any other questions? All right, cool. Well, have a good one, and I will post this both the lecture notes and the